You take a photo, it becomes HEIC. You send it to someone, it turns into JPEG. You download an image from a website, it's WebP. Your logo is PNG. Your designer asks for SVG, and none of these files behave the same. JPEG and JPG, JPEG, created by the Joint Photographic Experts Group in 1992, revolutionized digital photography by making high-quality images small enough to actually share. JPEG uses lossy compression, which means it deliberately throws away data to shrink file sizes. The technique it uses is called discrete cosine transform, which approximates image content using trigonometric functions. Basically, it looks at blocks of pixels and represents them mathematically rather than storing every individual pixel value. You can adjust how aggressively JPEG compresses, trading quality for file size. JPEG supports RGB and CMYK color spaces with 8 bits per channel, delivering 24-bit color. No transparency support, no alpha channels. JPEG became universal because it struck the perfect balance. Photographs compressed to manageable sizes while still looking good. Almost every camera, phone, and piece of software on Earth can read and write JPEG files. The file extension can be .jpg or .jpeg. They're identical, just different naming conventions from old operating system limitations. PNG stands for Portable Network Graphic and appeared in 1994 as a direct response to GIF's limitations. PNG stores compressed raster images using lossless compression, meaning you get smaller files without losing any image data. Unlike JPEG, PNG supports transparency through an alpha channel, which assigns transparency values to individual pixels. This makes PNG incredibly useful for website logos, video overlays, and any graphic that needs to sit cleanly on top of other content without a clunky background rectangle. PNG comes in 3 main flavors. PNG 8 offers 8-bit color with 256 colors maximum, similar to GIF but with better compression. PNG 24 delivers full 24-bit color with millions of colors available, perfect for detailed graphics. PNG 32 includes the alpha channel, allocating 8 bits each to red, green, blue, and transparency. The format only supports RGB color space, so it's not ideal for professional print work that requires CMYK. File sizes run larger than JPEG because nothing gets discarded, but for graphics that need sharp edges and transparency, PNG dominates. Web designers love it. Video editors rely on it for caption overlays. It's become the standard for any situation where quality and transparency matter more than absolute minimum file size. HEIF and HEIC. HEIF stands for High Efficiency Image Format, is the container that holds HEIC images. High Efficiency Image Coding. Apple adopted HEIC as the default photo format starting with iOS 11 in 2017, and it's now standard on iPhones and iPads. HEIC uses the same compression technology as HEVC video, also known as H.265, which is why it achieves roughly double the compression efficiency of JPEG at equivalent quality. A 10 megabyte JPEG photograph might compress to 5 megabytes as HEIC without visible quality loss. HEIC supports 16-bit color depth compared to JPEG's 8-bit, preserving more color information for editing. It also handles transparency and can store multiple images in a single file, which is how live photos work on iPhones. The format supports both lossy and lossless compression. Despite these advantages, HEIC adoption outside Apple's ecosystem remains patchy. Windows added native support in Windows 10, but you need to download a codec extension. Many Android phones can shoot HEIC, but default to JPEG for compatibility. Web browsers don't universally support HEIC, and sharing HEIC files with people on older devices often results in confusion and conversion headaches. iPhones automatically convert HEIC to JPEG when sharing to incompatible devices, which helps, but means you lose the file size benefits the moment you move images off your phone. WebP. WebP is Google's attempt to drag the web into the modern era by replacing JPEG, PNG, and GIF with a single format that does everything better. Released in 2010, WebP supports both lossy and lossless compression, meaning you can use it for photographs or graphics with transparency depending on your needs. The compression algorithms are more efficient than JPEG, producing smaller file sizes at equivalent quality levels, typically 25 to 35% smaller. WebP also supports alpha channel transparency like PNG, and can even handle animation like GIF, making it a legitimate 3-in-1 replacement. The format uses predictive coding to compress images, analyzing nearby pixels to guess what comes next, and only storing the differences. For web publishers, smaller images mean faster page loads and reduced bandwidth costs, Sounds perfect, right? The problem was adoption. For years, Safari refused to support WebP, fragmenting the web and forcing developers to serve multiple formats. Apple finally caved in 2020, and now WebP enjoys near-universal browser support. You'll see it increasingly on major websites, especially for hero images and graphics where file size directly impacts user experience. The downside is limited support in older software and devices, so WebP works great for web delivery, but remains awkward for archival storage or professional workflows. SVG. SVG stands for Scalable Vector Graphics, and it represents a fundamentally different approach to storing images. Instead of pixels, SVG stores images as mathematical formulas describing geometric shapes. A circle in SVG is defined by its center point, radius, and color, not by thousands of individual colored pixels. This means SVG images scale infinitely without losing sharpness. Zoom in 1000% on an SVG logo and it remains perfectly crisp, whereas a raster image turns into a pixelated mess. SVG was developed by the World Wide Web Consortium as an open standard and became the native format for Inkscape, the popular open-source vector illustration program. Every modern web browser can render SVG files directly, making them ideal for icons, logos, and illustrations on websites. Because SVG files are actually XML text documents describing shapes, they're also editable in any text editor. Though specialized vector software like Adobe Illustrator or Inkscape makes the process far more practical, SVG supports a wide range of color spaces and doesn't need alpha channels for transparency. You simply define which areas are transparent as part of the geometric description. File sizes for simple graphics are tiny compared to raster equivalents. The limitation is that SVG works beautifully for illustrations, diagrams, and graphics with defined shapes, but it's completely unsuitable for photographs or complex images with gradients and textures that can't be easily described mathematically. RAW formats preserve the pure sensor data from digital cameras before any internal processing happens. When you shoot JPEG, the camera makes decisions about color balance, sharpness, and contrast, then throws away the original sensor information. RAW keeps everything. RAW files offer RGB color space with 12, 14, or 16 bits per channel, depending on your camera model, giving photographers enormous latitude for adjusting exposure, white balance, and color grading after the fact. Here's the annoying part. RAW isn't a single format. Every camera manufacturer created their own proprietary version. Canon cameras save CR2 files, which stands for Canon RAW version 2. Nikon uses NEF, or Nikon Electronic Format. Sony uses ARW, Panasonic, Leica, and Casio actually use the .RAW extension. Adobe created DNG or Digital Negative as an open RAW standard, but adoption remains mixed. You need specialized software like Adobe Lightroom, Photoshop, or manufacturer-specific utilities to even open RAW files. Most basic image viewers choke on them completely. RAW files are massive compared to JPEG, and you can't directly share them or upload them to websites. You process RAW files to extract the maximum quality, then export to JPEG, TIFF, or whatever final format you need. ICO and ICNS. ICO and ICNS are specialized formats designed specifically for operating system icons. ICO is Windows icon format, while ICNS serves the same purpose on macOS. These formats don't care about photographic quality or professional printing. They exist solely to provide the tiny graphics that represent applications, files, and folders in your operating system interface. Both formats can store multiple resolutions of the same icon within a single file. This matters because operating systems display icons at different sizes depending on context. A small icon in a file list, a medium icon on the desktop, a large icon in an application switcher. Rather than scaling a single image and getting blurry results, ICO and ICNS files contain pre-rendered versions optimized for specific pixel dimensions like 16 by 16, 32 by 32, 64 by 64, and so on. Windows ICO files can store images from 1-bit monochrome up to 32-bit color with alpha channel transparency. ICNS files follow similar principles but use different internal structures suited to macOS requirements. Modern operating systems also support higher resolution displays, so icon files now include even larger versions to look sharp on 4K monitors and Retina displays. You'll rarely create or edit these files unless you're a software developer, packaging an application, or customizing your system appearance. Specialized tools exist for creating icons, but general-purpose image editors often struggle with the multi-resolution container aspect that makes ICO and ICNS unique. BMP or bitmap image file, is Microsoft's ancient gift to the computing world. This format stores images as raw, uncompressed grids of pixels, what we call raster graphics. Each pixel gets its own color value, and nothing gets thrown away. No compression tricks, no smart algorithms, just pure pixel data stacked into a file. This means BMP files are massive, but they're also dead simple. Early Windows needed something straightforward that any program could read and write without fancy decompression routines. BMP delivered exactly that. It became the default image format baked into Windows Paint and countless other applications. The downside? A high-resolution photograph saved as BMP can easily balloon to tens of megabytes. BMP supports RGB color spaces and can handle 1-bit, 4-bit, 8-bit, or 24-bit color depths, but it's essentially a dinosaur now. Useful for specific technical applications where absolute raw data matters, but generally replaced by smarter formats everywhere else. GIF, the Graphics Interchange Format, arrived in 1987 courtesy of CompuServe. This format uses lossless compression, meaning it reduces file size without discarding information. The catch? GIF only supports 8-bit color, limiting images to a maximum palette of 256 colors. This sounds restrictive, and it absolutely is, but back when dial-up internet crawled along at snail speeds, every kilobyte mattered. GIF made simple graphics and logos downloadable without waiting forever. The real magic trick GIF pulled was animation support. You can stack multiple frames inside a single GIF file, creating those looping animations that dominated early web culture and somehow never died. GIF uses run-length encoding compression, which works by storing sequences of identical bytes as a single value followed by a count. So if your image has a large solid colored area, GIF compresses it efficiently. For photographs with smooth color gradients, GIF is terrible. Those 256 colors create visible banding. But for flat color illustrations, simple animations, and memes that refuse to fade into internet history, GIF remains stubbornly relevant. TIFF, the tagged image file format, first appeared in 1986 with its specification last updated in 2002. This format was designed for professional graphics work, particularly printing and scanning applications. TIFF stores raster images and offers ridiculous flexibility in how it does so. You can save TIFF files with no compression at all, with lossless compression, or even with lossy compression depending on what options you choose. TIFF supports RGB and CMYK color spaces as well as pure black and white images. Bit depth goes from 8 bits per channel all the way up to 32 bits per channel, giving professional photographers and designers massive flexibility for image manipulation without degradation. TIFF also supports alpha channels for transparency. Because it handles CMYK color, TIFF became a standard format for preparing images for professional printing presses, where color separation matters. Some high-end digital cameras can shoot directly to TIFF, though the file sizes are enormous compared to JPEG. The format enjoys wide software support across professional applications. TIFF files can also store multiple pages or layers within a single file, making them useful for scanned documents. The trade-off is file size. Uncompressed TIFF images are huge, which is why they're rarely used for web publishing but remain common in print workflows. PSD and XCF. PSD, or Photoshop Document, is Adobe Photoshop's native file format and the dominant standard for professional raster image editing. PSD files are not meant for sharing or final delivery. They're working project files that preserve every editing decision you make. The format stores images in multiple layers, each of which can be independently edited, moved, masked, or blended with other layers. Each layer can contain its own alpha channel for transparency control. PSD mainly stores raster image data, but it also saves text and certain graphic elements as vectors, which keeps them editable and scalable without resolution loss. This means you can change text content or resize a shape layer without degradation. PSD supports RGB and CMYK color spaces as well as grayscale and pure black and white images. Bit depth goes from 8 bits per channel up to 32 bits per channel for high dynamic range workflows. The format also preserves adjustment layers, blend modes, layer effects, and smart objects. Basically everything you need to maintain full editing flexibility. PSD files are typically enormous because they contain all this layered data uncompressed or with minimal compression. While proprietary to Adobe, many other image editors can read PSD files with varying degrees of success. XCF is the equivalent format for GIMP, the open source photo editor. It serves the same purpose, preserving layers, masks, and editing data, but in GIMP's ecosystem rather than Photoshop's. Neither format is suitable for web publishing or casual sharing. You export finished work to JPEG, PNG, or TIFF when you're done editing. PDF and EPS. PDF, the portable document format, was created by Adobe in 1993 to solve a fundamental problem problem. How do you share a document that looks identical on every computer regardless of what software or fonts the recipient has installed? PDF became that universal standard. While primarily known for documents, PDF is also a legitimate image container format. Like EPS, PDF is largely vector-based, storing text and graphics as mathematical descriptions that scale perfectly. But PDF can also embed raster images, allowing photographs to sit alongside text and vector illustrations in a single file. This makes PDF ideal for final artwork delivery, technical documentation with diagrams, and any situation where you need a self-contained file that preserves exact layout and appearance. PDF supports RGB and CMYK color spaces, multiple bit depths, and can even include transparency and layers depending on the PDF version. EPS stands for Encapsulated Postscript, and it's a veteran of the print publishing world dating back to the late 1980s. EPS is primarily vector-based, but can also embed raster images within the file, allowing you to mix resolution-independent logos and text with photographs or scanned elements. This flexibility made EPS the standard for exchanging artwork between design programs and preparing files for professional printing. Modern workflows have largely moved away from EPS toward PDF, but you'll still encounter EPS files in legacy print environments. AVIF. AVIF stands for AV1 image file format and represents the cutting edge of image compression technology. Released in 2019, AVIF is based on the AV1 video codec, which was developed by the Alliance for Open Media as a royalty-free alternative to proprietary video formats. By using video compression techniques on still images, AVIF achieves remarkable file size reductions, often 50% smaller than JPEG at equivalent quality, and significantly better than WebP in most comparisons. AVIF supports both lossy and lossless compression, handles high bit depths up to 12 bits per channel for HDR images, and includes alpha channel transparency. The format also supports animation, making it a potential replacement for GIF and animated WebP. Image quality at low bit rates is particularly impressive, where heavily compressed JPEGs fall apart into blocky artifacts. AVIF maintains smoother gradients and better detail retention. Browser support has grown rapidly, with Chrome, Firefox, and Safari all adding AVIF support between 2020 and 2021. The main challenges are encoding speed. Creating AVIF files takes longer than JPEG, and limited support in older software and devices. AVIF is clearly positioned as the next generation image format for the web, offering superior compression for bandwidth-sensitive applications. As encoding tools improve and support spreads, AVIF will likely replace JPEG for many web use cases, though universal adoption will take years. APNG, or Animated Portable Network Graphics, was created in 2004 by Mozilla developers who were frustrated with GIF's limitations. A PNG extends the PNG format to support animation while maintaining PNG's advantages: full 24-bit color, alpha channel transparency, and lossless compression. Unlike GIF's 256-color palette, APNG animations can display millions of colors with smooth gradients. The transparency support is particularly valuable for animated overlays and graphics that need to sit cleanly on variable backgrounds. PNG files are backwards compatible with regular PNG. Software that doesn't understand animation will simply display the first frame as a static image. This made APNG safer to deploy on the web compared to entirely new formats. Despite these advantages, APNG struggled for adoption. Browser support was inconsistent for years, with Chrome and Internet Explorer refusing to implement it while Firefox and Safari supported it. This fragmentation meant web developers couldn't rely on APNG working everywhere. Additionally, file sizes tend to run larger than animated GIF for equivalent content because APNG uses lossless compression. The format found niche uses. Apple adopted APNG for iMessage stickers, and some websites use it for high-quality animated graphics. But APNG never achieved the universal status its creators hoped for. With modern formats like WebP and AVIF now supporting animation with better compression, APNG's window of opportunity has largely closed. It remains a technically superior alternative to GIF, but one that arrived too late and lacked the industry momentum to replace the ancient format it was meant to kill. Speaking of confusing standards, ever wonder why USB ports come in blue, black, red, and yellow? The color coding system involves more chaos than you'd expect. Check out the video on screen.